Good morning, my dear students. Our lesson today, analyzing rational numbers by using models. What is a rational number? A rational number is any number that can be written in the form a over b, like a fraction, where a and b are integers and b not equal to 0. For example, numbers like 5, -3, 0, 3 and 1 over 8, 0.28 can be written in the form a over b as 5 can be written as 5 over 1. All whole numbers can be written as a fraction. Its denominator is 1. Also, -3 over 1, 0 over 1. Now, we have 3 and 1 over 8. So we will convert it from the mixed number to improper fraction. How? We fix the denominator 8 and we multiply 3 and 8 and then we adding numerator 1. 3 times 8 equals 24. Adding 1 that equals 25. So we converted 3 and 1 over 8 to 25 over 8. The last one, 0.28, can be written as 28 over 100. We can multiply 10 up and down and we get a new fraction equal to this decimal number is 280 over 1000. Analyzing numbers using Venn diagram. Note that any group of numbers is called a set. For example, the set of rational numbers which contains integers, natural, counting, and decimal or fractions. Also, we have set of integers which contains counting, zero, and negative numbers. Second note, each rational number is called an element of the set of rational numbers, which means that 1, 3, half, and -3 are called elements of the set of the rational numbers. Now, the following diagram represented the relation between rational, integers, naturals, and counting numbers. The rational number is the biggest set. It contains integers and not integers like fractions and decimal. Integers, we have two groups or two sets. The first set is the negative numbers, which -1, -2, -3, and so on, and natural numbers, which contains 0 and the counting numbers. Exercise number 1. Write the following numbers in the opposite Venn diagram. We have 3 over 4, 782, 0, -10, -0.5, 15, -6, and 7 and 12 over 13. The first number is fraction, so we will put it in the rational numbers on the circle of the rational. Second number is 782, which is a counting number, so we will put in the smallest circle. Then we have 0. 0 is an element of the set of natural numbers. Next, -10. -10 is one of the elements of the integers. And then we have -0.5. The set of decimals and fraction is the rational numbers. So we will put in the biggest circle. And then we have 15. 15 is one of the counting numbers. -6 is one of the integers. And 7 and 12 over 13 is a mixed number which can write as a fraction, so we will put it in the rational numbers. In exercise 2, write the given rational numbers in the fraction form a over b. We have in letter A -3, which is a whole number, so we will write in the numerator -3 and in the denominator we will write 1. Letter B, we have negative 0.31. We will change from decimal form to fraction form. We have two decimal places here, and we will put 100 in the denominator and write the number 31 in the numerator. Letter C, 3 and 2 over 5, which converted from mixed number to improper fraction. So we will get 5 in the denominator, and we multiply 3 times 5, we get 15, plus 2 equals 17. So we will get improper fraction 17 over 5. On letter D, we have 2.5, 5 in the tenth, so we have only one decimal place in the decimal part, so we will put 10 down and we write 25 in the numerator. Exercise 3. Matches the numbers to the best subsets. We have rational number, integer, counting number, and natural number. On letter A, we have 0.785 thousandths. This is a decimal which is belong or matches to the set of rational numbers. Letter B, 3 over 7 is a fraction which is on the rational numbers. Letter C, we have negative 428, which included in the set of integers. Letter D, negative 3, which includes in the set of integers. Letter E, 0. 0 is included in the set of natural numbers. Letter F, negative 13,274, which included in the set of integers. Letter G, 4, which included in the set of counting numbers. Letter H, 17,273, which also included in the counting numbers. Exercise 4. Choose the best subset of the following for each number. Again, we have rational, integer, counting, and natural. 0 is space number. 0, first set we see 0 on 8 is the set of natural numbers. Letter B, negative 2 over 3 is space number. Negative 2 over 3 is a fraction, so we will put it on rational number. C, we have negative 4. Negative 4 is an integer. And last one, letter D, 5 is a counting number. Okay. Belonging of an element to a set. Belong and doesn't belong is a relation between element and set. Exercise. Write belongs or doesn't belong. If we have exercise like exercise A, negative 3 over 7, we're looking for if this fraction is belong to the set of integers or not. The set of integers contains positive, negative, whole numbers, and 0. So, negative 3 over 7 as a fraction doesn't belong to the set of integers. Letter B, we have here 0 and the set of natural numbers. Set of natural numbers contains 0 and 1, 2, 3, and so on. So, 0 belongs to the set of the natural numbers. Letter C, we have negative 4 and the set of the counting numbers. Counting numbers is a set which contains 1, 2, 3, and so on. So, we have no negative there. Negative 4 doesn't belong to the set of the counting numbers. Last one, letter D, 0, space to the set of rational numbers. The rational number is the mother of the set. We have all numbers and all decimal and all fractions on this set, so 0 belongs to the set of the rational numbers. Inclusion and subsets. Set of counting numbers is a subset of the set of the natural numbers. It's a part of the set of natural numbers. Okay? Or the natural numbers includes set of counting numbers, as counting numbers is a part of the natural numbers. Set of rational numbers isn't a subset of the set of integers, because set of rational numbers have more elements than the set of the integers. So we have another expression: set of integers is a subset of the rational. Integers is a part of the rational. Or the set of rational numbers includes a set of integers. So we have a subset and not subset is a relation between two sets. Now we have exercise 5. Write a subset or not subset. The set of integers is space of the set of the counting numbers. Set of integers have counting 0 and negative numbers, so it can be a subset of counting numbers. Counting numbers only have 1, 2, 3 and so on, so isn't a subset. Letter B, the set of natural numbers is space of the set of integers. So set of natural numbers which contains 0, 1, 2, 3 and so on, and the set of the integers contains negative and positive and 0, so it's a subset of the integers. C, the set of counting numbers is space of the set of the rational numbers. Set of the rational is the mother of the sets, so counting is a subset of this mother. Letter D, set of rational numbers is a space of the natural numbers. Rational is the biggest one, and natural is a small set, only have 0, 1, 2, 3 and so we can't put rational number as a part of natural, so it is not a subset of the set of the natural numbers. Set of counting numbers, and letter E, set of counting numbers is space of the set of integers, so counting is subset of the integers. Counting contains 1, 2, 3 and so on, and integers also have this part. Representing rational numbers on the number line. We talked before about number line. We have 0 in the middle, the positive number on the right, and the negative numbers on the left. Note that 0 is neither positive nor negative. So, if we have an example, represent the rational number 3/4 on the number line. Take this note as 0 can be written as 0/4 and 1 we can write it as 4/4. If we take the number line from 0 to 1 and divide it for 4 parts, we can write 0 as 0/4, 1/4, 2/4, 3/4, and 1 as 4/4. So we will put A, the point of 3/4, after 3 places from 0. The point A represented the rational number 3/4. Letter B, the two rational numbers 3/4 and negative 3/4 represented on the number line as the following figure. If we distribute the distance from 0 to 1 for 4 parts, we can put 3/4 after 3 parts from 0, and also negative 3/4 we can put it on the left side after 3 places from 0. The rational number negative 3/4 in the opposite of the rational number of 3 over 4. Okay, exercise 6. Write the opposite or the additive inverse number of each of the following. We talked about the opposite or the additive inverse before, as we only change the sign of the fraction or the number. Here we have in letter A 3 over 7, so we will convert it to negative 3 over 7. On letter B we have negative 2 over 5, so we will convert it to 2 over 5. Letter C have, we will convert it to negative 1 over 2. D, negative 3 over 2, we will convert it to 3 over 2. E, first we have 2 and 1 over 3. We have to convert it to from mixed number to the improper fraction. So we will get 7 over 3. And then we change the sign, so we will get negative 3 over 7. Sorry, negative 7 over 3. We change only the sign. So we will convert from positive to negative. Letter F, we have 0. 0 is neither positive nor negative, so it will be 0. On exercise 7, graph each rational number on the number line. Letter A, 1.5, half, negative 2.5, and negative 3.5. We have 4 points here. All of them have half, so we will distribute the number line to halves. 0 over 2, this is 0, then half, 2 over 2, that equal 1, 3 over 2, and then 4 over 2, which equal 2, 5 over 2, and then 6 over 2, which equal 3, and so on, from the positive and the negative. The first one, 1.5, 1.5 is equal 1, and then we move one step to the right, we get 1.5, which equal 3 over 2. And then we have half. This is the first number on the right after 0. Negative 2.5 on the left, we will move till negative 2, and then we move one more step, you will get negative 2.5 or negative 5 over 2. Negative 3.5, we will move to the left till we reach negative 3, and then we move one more step in the left, we get negative 3.5. Letter B, how would we graph negative 1 and 1 over 4, 2.25, negative 1 over 4 on the number line? First, we will distribute the number line to quarters or to 1 over 4. So we will get 0 over 4, 1 over 4, 2 over 4, and so on. We get 1 on 4 over 4 and 2 on 8 over 4. Negative 4 over 4 equal negative 1, and negative 8 over 4 equal negative 2. The first one, negative 1.25. So we will move to reach negative 1, and then we move one more step to the left, and we get negative 1.25. 2.25, we will move to the right till we reach 2, and then we move one more step to get 2 and 25 hundredths. Negative quarter, we will move from 0 one step to the left. Thank you.